Welcome, ladies and gentlemen, to lesson 4.2. Now, this information is very similar to what we did back in chapter 3. We're going to go ahead and solve, but again, it's solving inequalities, which means we are going to graph towards the end. So our essential question, how can you use addition or subtraction to solve an inequality? We're going to use what again is called our inverse operations. So your objective, I can solve inequalities using addition or subtraction and maybe even solve some real life problems. So if you notice, you've got your basic inequality given to you. X plus 11 is less than or equal to 7. We're going to graph the solution as soon as we finish solving it. So I'm just going to make it a little bit bigger. You can just write it once, really big there. My inverse operation, again, it has a positive or plus 11. I would like that to become a 0 or disappear. So I'm going to go ahead and subtract 11 on both sides. Let's see, there it goes. So x is isolated, is less than or equal to, and 7 subtract 11 is just a basic -4. It is all completed. If you notice, you have your variable x on the left-hand side like we desire. And then we're going to go ahead and make a quick graph. So I'm going to switch to my pen. And remember, the basics that I want from you is just a nice number line there. We're going to put the important number in the middle. So let's see, -4 goes there. And I want a number on the left and a number on the right. And if we count backwards, it goes -3, -4, -5. According to our previous information in lesson 4.1, it has a closed dot. Therefore, I'm going to go ahead and make a circle and fill it in. Close. I'm going to make it abnormally large, larger than I would normally make it. And then remember, we're going to go ahead and shade to the left or the right dependent upon our inequality. Since the variable is on the left side, we can say it's pointing to the left, or we can say the words is less than, and to the right would be -2, -1, 0, all the positives, and those are definitely the greater than. So I'm going to avoid the right side and shade to the left side. And again, it's pointing to the left. I'm just going to go ahead and shade it to the left. Again, you can use your highlighter if you'd like to. Maybe make it a little bit quicker. It just needs to be looking like it's to the left. Perfect. All right. Ooh, this one's going to be very interesting because if you notice, our variable is not on the left side. So in order to solve this one, I'm going to ask my students to fix it now instead of fixing it later. Because again, we ultimately want the variable on the left side. So if I do that, n subtract 19 will no longer be on the right side, it'll be on the left side. And -8 will be on the right side. But notice this. Notice the inequality. It wants to, quote unquote, eat the n subtract 19. Remember when you're in elementary school, the crocodile wants to eat? Yeah. So in other words, it is open to the variable side. So it means when I rewrite it, it is still open to the variable side. So I'm not switching anything like that. I'm just keeping it open there. So for example, if you're like in the classroom and someone's walking around with a pizza, you would be continually following that information. Or the pizza, your mouth would be, I want to eat the pizza. Same thing here. The crocodile wants to eat the variable. The inequality is open towards the variable. All right. Now we're going to go ahead and add 19 to both sides. Because -19 plus 19 is zeroed out, it disappears. So that means we have n is greater than, and -8 plus 19 is going to be 11. Remember our integer rules from chapter 1, different signs, subtract, and take the sign from the greatest absolute value. All right, now that I have it solved, I can go to make a quick graph. And remember, we got our number line. 11 goes in the center. So we have 10, 11, 12. According to our inequality, it is an open dot. I'm not going to shade it in because it does not have the equal part. And then again, the trick is, since the variable's on the left side, like we wanted, it looks like it's pointing to the right, or the words is greater than, And we know that 12 is greater than 11, and that's on the right side. So again, both ideas tell me to shade to the right. And again, got a simple arrow there. Highlighter, maybe even, I wouldn't say a Sharpie because that would probably go through your notes. Or just your nice good pencil. All right. Solve H, subtract. Oh, we got some mixed numbers. That's okay. We can still be awesome. Then graph the solution. So I'm going to use my inverse operation again. I'm going to go ahead and add 1 and 1/2 to both sides. And if you notice, they're both positive, so that means I can just add them together, which would give me 6.5. If it's helpful, you can technically think of a decimal. We're probably not going to think of an improper fraction, though, because when we graph it, an improper fraction is not as easy to graph. So 6.5, yeah, that's going to be in the middle. But normally, we don't put just 6.5 in the middle. So imagine this is 6. This is 7, 8, 5. 6.5 would go in the middle of 6 and 7. So just going to put an open dot in the middle of 6 and 7 because that's where 6.5 goes. Left, or the words is less than. So again, shade to the left. So if I were reading off the answer again, I would say open dot on 6.5, shading left, or to the left, or open left. And that's exactly what we have there. On a multiple choice quiz, you might have multiple graphs to choose from. Maybe they're all open dots, but some are going to the left, some are going to the right. And maybe they don't have the same number that we need, 6.5. Maybe they have it at 5.5. Now, obviously, you would choose the correct one. All right, we got 3 quick ones. We're just going to go ahead and solve them and graph them really quick. So on our first one, we're going to add 6. That's weird. Y is greater than -7 plus 6 is -1. So again, quick graph. Important number goes in the center, -1. Backwards counting, 0, -1, and -2. We're going to say open dot on -1 and to the right. Very nice. Number 2, we're going to add 3.8. Again, how weird. B is less than or equal to, and when we add it up, again, we get a 5, or really 15, so a 5.5. So a 5.5 again is going to be in between 5 and 6. It's going to be a closed dot and arrow goes to the left, shading to the left. How silly. Don't know about those random straight lines. All right, number 3. This is what we want to focus on. A few complicated ideas. First of all, let's switch sides. And if you're okay with it, let's change this to a letter N. Oh my goodness, that's so silly. Let's change it to an N. So that's going to be an N subtract 1/4. And then the 1/2 is going to go. That's so weird. I'm so sorry. Let's try it again. N subtract 1/4. Then I have a 1/2. And according to the original problem, a little hard to see, it wants the half. So the inequality is open to the half. There we go. Now I'm going to go ahead, and if you notice, all of them are consistently adding. So I'm going to add 1/4. So it's going to give me N is less than, and then remember, you cannot add them currently because they do not have the same denominator. That's from chapter 2. So that means I'm going to go ahead and multiply this by 2. and that's going to give me 2 over 4. So 2 over 4 plus 1 over 4 is 3/4. And if you were to graph that, that would be in between 0 and 1. Because 3/4 is really 75 cents, which means your open dot's going to be a little bit closer to the 1. If you put it in the middle, then that means you think it's a half. But it's not a half, it's 3/4. So I'm going to put an open dot closer to the 1. Now, it doesn't have to be super accurate, but it shouldn't look like it's in the middle. All right, and to the left. Excellent. Remember, if you need it, you can back up the video and watch it again. All right, last one, I think. Your brother has $2,000 saved for a vacation. His airplane ticket is $637. Write and solve an inequality to find how much he can spend for everything else. That includes hotel, food, souvenirs, adventures, things like that. So the thought is the $2,000 and the $637, that needs to be definitely in our inequality. And the inequality, again, is similar to an equation, except you have an equal sign, it has the actual inequality sign. Everything else, well, that's the unknown. So we're going to go ahead and find the inequality and then solve the inequality. All right. So x, that's our variable. You can say n if you want to. The amount he can spend on that everything else. Those two items added together, the amount he can spend on everything else plus the plane ticket cannot be greater than $2,000. It has to be less than or equal to $2,000. That's the total he saved, right? So our unknown plus 637 is less than or equal to 2,000. So we got a basic subtraction problem. And if you're really careful, it comes out to less than or equal to $1,363. Now, maybe he doesn't want to spend all of that, but he can. Sometimes it's always wise to travel with some cash at the end of your trip in case you need to buy something at the airport. So maybe he shouldn't spend all that money, $1,363, at the destination. And I'm going to go ahead and say we skip the fighter pilot one. Or if you want to, just watch it really quick. So the max is 6 feet 5 inches. Your friend is 6 feet 3 inches. He's still going to grow. I wish, right? So the current height plus the height your friend can grow has to be less than or equal to 6 feet 5 inches. 5 over 12, again, is the inches. 3 over 12 is the inches. We know that we can go ahead and write it like this. When we subtract the 6 and 3/12, that gives me 2/12, which we know is really 1/6, or it's really just 2 inches. My uncle tried to be a fighter pilot in the Air Force, but his vision did not allow him to do so. Now, you think there would be a height limit, right? Because you can't have a superstar NBA height and be in the airplane or the fighter jet. Gotta have height restrictions sometimes. All right, be awesome.